Hi, welcome to my video on the sum of the exterior angles of a polygon. Previous video we did the sum of the interior angles. Now we're going to do the exterior angles. But I need the sum of the interior angles to help explain the exterior. Let's start. An exterior angle of a polygon is formed by extending only one side at a vertex. So if I take A and extend it out there, then I have an angle. Or I can take A and extend this side out and get this exterior angle. Notice this is interior, that's exterior. That's exterior, that's interior. So there's only one interior exterior angle at a vertex in order to do what we're doing. And then at B, if I want to come down here and extend that out, then there's the exterior angle. Or I can go over here and extend this side out and get this exterior angle. And at C, I can extend out that way to get that exterior, or I can extend it out this way to get this exterior. So it don't make a difference how you do it, but if you want to go around in order, then here we go. If I go like this and extend that out, then I keep coming down here and extend that out. I got this exterior, and if I want to go like that, I extend that out, and there's the exterior. So it don't make any difference as long as you extend only one side out. So extend that at P, Q, R, T. There's the exterior angle at P. Let's keep going in the same direction. At Q, keep going in the same direction as if I were walking around. There's the other exterior angles. And pretend I'm walking. Extend as I go. Extend. And I have this exterior angle right here. Remember, these angles I'm marking with X are all interiors, and the angles marked with the strokes are exteriors. And this is the same here. You can, no matter how you do it, there's the exterior, and you go out there, there's the exterior, or you can go out there, exterior, or you can go out here. It makes no difference how you extend it. Only one exterior. There are two by doing do, but to explain how I'm going to get the exterior, you only do one. So at E, like that, at F, like that, at T, or at H, sorry, at I, and at J. So there's the exterior angles. And if they're exterior, then that's the interior, right there. That's the exterior, that's the interior, 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 interior. Interior angles around the inside, the exterior angles around the outside. Let's continue. Practice. Pause your video and name the exterior angles in each of these diagrams. So at this vertex right here, 3 is the exterior angle. At this vertex, 6 is the exterior angle. At this vertex, 5 is the exterior angle. 1, 2, and 4 are interior. Number 2, interior angles are 2, 4, 6, and 8. So at 2, the exterior angle is 5. At this one, vertex, the exterior angle is 3. And at this vertex, the exterior angle is 1. And at this vertex, the exterior angle is 7. So let's find the sum of the exterior angles. Follow my procedures I'm going to do for you. Let's follow these steps. Let's draw an exterior angle. We draw the exterior angles. So draw that one, and we draw that one, and we draw that one. So A is done. I have the 3 exterior angles done. B says number the pairs of interior and exterior. The number of pairs of interior, exterior. So there's 1 interior, exterior. Interior, exterior is 2. There's another pair, so that's 3 pairs altogether. 1, 2, 3. Notice they form a straight angle. And C is find the measure of 1 pair. So 1 pair, the measure of 1 pair. Since that's exterior and that's interior form a straight angle, the measure of one of the pairs is 180. 180 there, or 180 here, only one of them. D, multiply B and C. So 3 times 180 gives you 540. And notice that 540 is the sum of the interiors and the exteriors in the whole figure. E, find the sum of the interior angles. Well, we have 180 times n minus 2 is the formula we learned earlier. 180, we have 3 sides. And really, I didn't have to do this because most people know that there's 180 degrees in a triangle. But I worked out the formula for you, but I could have wrote down 180 right away. And F is, you take all the angles, which is in D, and you subtract the interior. So if this is all the angles, 540, and that's the interior, by subtracting, you get the exterior. So if we take all the angles, measures of all the angles, and subtract the interior, you'll get the sum of the exterior, which is 360. So let's do that again. And let's extend the sides out. So we go 1 there, 1 there, there. So I've extended the sides out. So that's done. And I have how many pairs? 1, 2, 3, 4 pairs this time. Because I got triangle got 3 sides, 3 exterior angles. If you do 1 in each vertex. And a quadrilateral got 4 sides, 4 interior, 4 exterior. So for each interior angle, you have 1 exterior. So there's 3 exterior, 3 interior. 4 interior, 4 exterior. And the sum is 180 is for this is a straight angle, so it's 180. So I just need to do one of these is 180. So I have 4 times 180, which is 720. So all the angles add up to 720. And the interior angles, well, let's figure it out. 180 times n minus 2. I have 4 angles. So 180 times 2 is 360. So all the interior angles add up to 360. And that's true because you got a quadrilateral. And a quadrilateral, if you notice a quadrilateral very quickly, a quadrilateral has 2 triangles. So it's 180 each. It's 180 times 2. And if you take all the angles, which is 720, and subtract the sum of the interior angles, which is 360, when you subtract those two, you get a 360. So what number are you getting? So the exterior angles always add up to 360. So the sum of the exterior angles of any polygon is 360. Again, I did these two for you and to come up with the 360. Again, if you keep that in mind, what's happening, then you're always using, and you never forget if you learn how to derive it. That's what I found in math. When I started learning how to derive it, then if I forgot it, I could go back and work it out again. Now let's find the measure of each exterior angle of a regular polygon. So the formula is the sum of the exterior angles, which is 360 now. This is not interior, would have been 180 times n minus 2. But exterior is sum of the exterior is 360 divided by the number of exterior angles, which is the same as the number of interior angles. A triangle has, find the measure of each exterior angle of a regular polygon. Triangle has 3 sides, so the sum of the exterior angles is 360 divided by the number. So that gives me 120. Pentagon is 5 sides. So what's the sum of the exterior angles? 360 divided by 5. 5 into that. 320. So just 5 6s, 5 7s, 5 sevens are 35, and we get a 10, so it's a 72. Or you can use your calculator. And a nondegon got 10 sides, so that's 360 is the sum of the exterior angles divided by 10. Cancel your zeros, you get 36. Notice the more sides you have, the smaller the interior angle. And the dual dectagon is 12. So the sum of the exterior is 360 divided by 12. 12 into 36 is 3. So a dual dectagon has, each angle is 30. And just to draw the pentagon, go back to the pentagon again. 1, 2, 3, 4, 5. So notice each angle is 72. Each exterior angle, sorry, I'm thinking different now. Each exterior angle is 72. And you keep going around, and you got right here 72, and right there 70. So each exterior angle is 72. If you notice, you have the 180 for the interior angle. Okay, practice. You work these out and play it back when you're finished to see if you got the right answer. Quadrilateral, 4 sides, 360 divided by 4. Quadrilateral has, you see, if it's regular, it's a square. All the sides are equal. All the angles are equal, so it must be 90. Makes sense. 360. A hexagon. Hexagon has 6 sides, so it's 360 divided by 6, which is 60 degrees. 6 into 36 was 6. Dectagon is, look at this, my mistake. Dectagon is 10 sides, so we get 36. Now I notice a nondegon is 9 sides. Just notice my error. So 9 into 36 is 40 degrees. Sorry about that. Again, one of those things I normally make an error, and I always told my students, if I make an error, please tell me about it. We're only human, and I have a tendency to make some errors in my teaching, so apologize, but in my videos, I will normally make an error most times when I do a presentation. Fine. Sorry about that. And an octagon is 8 sides, so it's 360 divided by 8. It's the sum of the exterior divided by each interior. And 8 divides into 36. 4 eighths are 32. Subtract and you get a 4. 8 into 40 goes 5. So each exterior angle in an octagon is 45 degrees. Let's do the hexagon. 1, 2, 3, 4, 5. That's not a very good hexagon. Regular one. Let's see if I can do a better one. 1. This is a better one. Now that's better. 6 sides. So let's extend the angle. So that's a 60. Let's extend this angle. That's a 60. Let's extend this angle. So that's a 60. And let's extend this one. Oop, I ran out of exterior angle 60 there. Extend this one, 60 there. And if I extend this one, there's 60 there. So the exterior angles are all 60. 60, 60, 60. And the interior, 120 for each of these. Check it out. So let's working out the exterior angles always add up to 360 in every polygon. If you take the 360 and divide it by the number of angles, you'll get the size of the exterior angle. The size of the exterior angle. Again, note, if you got a polygon and you extend the side, there's the exterior angle. So all of them add up to 360. And if you divide 360 by n, you'll get each exterior angle. That's the size of each exterior angle. 360 divided by n. And if you like my video, then you can click on my like button, subscribe button, my notification bell, and if you want, write a comment. And you can visit my math website at www.mathfullyexplained.com. There you'll find information about in different sections. One is on me, one is on my videos, teaching styles I'm going to use, and the most important one is the section on content. Gives you the topics that's on my YouTube channel and the number of videos on each topic. Because if I got a topic of factoring and I have 15 videos, then they're done in sequence, so that's nice to know. And the black font is what's already online. The red font is what will be there in the near future. Thank you very much. Bye-bye.